Hi everyone, welcome to Differential Calculus. Today we explore lesson 2.5, continuity and the intermediate value theorem. Number one, continuity definition. A function fx is continuous at x equals a if limit x approach a, fx is exactly f of a. That is, we can do the direct substitution. There are cases in which a function is not continuous. First case is when we have something like this. A whole. Second case is something like this. A gap. And then the next case is you guys can guess it. A vertical asymptote. There is a theorem that is very important that I want to cover. And they say that the following functions are continuous everywhere in its domain: polynomial, radical, rational, exponential, logarithmic, trigonometric, and inverse trigonometric. Let's take a look at some example. Example, find C so that fx is continuous everywhere. To do this, we're going to use the definition of continuity. That is, we're going to find limit x approach, well, the number 2 here, 2, fx, and make sure that it is exactly f of 2. Limit x approach 2. We got to use the piece that x does not equal to 2. So that is cx squared plus 2x. And we can do the direct substitution if x is exactly 2. So it's the second piece. 2 to 3 minus c times 2. Yay! And then from here, we can do a direct sub. C 2 squared plus 2 times 2, 8 minus 2c. So we have a 4c plus 4 equal 8 minus 2c. 6c equal 4. C is 4 over 6, which is the same as 2 over 3. Yay! Not too bad. Continuity is very useful, and one of the use of continuity is in defining the intermediate value theorem. This is what it says. Suppose that f is continuous on the closed interval a to b, where fa is not the same as f of b, then there exists a number c in the open interval a and b, so that f of c is between fa and fb. Intermediate value theorem is very useful to identify whether a function has a 0 or not without solving for the 0. Let's take a look at the graph here. Here's x, here's y. So let's say we have a function going like this. If we pick this to be A, then this would be f of A. We can pick this to be B. And we have f of B. Because the function fx is continuous on the closed interval A to B. As you can see, there's the number C right here. So that f of C is 0. It's between FA and FB. And C right here is the 0 of the function. Okay. Let's do an example. Example, does fx equal 2x plus cosine x have any 0? To find 0, we set fx equal to 0 and solve for x. 2x plus cosine x equal to 0. As you can see, not easy. To solve for x, which is why we're gonna use the intermediate value theorem. Because the question only asked us for, does it have any 0? Two x is continuous everywhere. Same thing for cosine x. So when we take 2x plus cosine x, the function is continuous everywhere. Next, we just have to pick a number so that the output is negative and another number so that the output is positive. F of negative pi of 2, right? So it's going to be a 2 times minus pi of 2 plus cosine of minus pi of 2. And this gives us the negative pi. F of pi of 2. 2 times pi of 2 plus cosine of pi of 2. Oh, this is pi. From the intermediate value theorem. Intermediate value theorem tells us that there is a number C between negative pi of 2 and pi of 2, so that f of C is between f of negative pi of 2 and f of pi of 2. We see that f of C is between negative pi and pi. So meaning that, yay, f of C can be 0. Right? And this tells us that C is a 0. We don't know what it is, but we know this one from the intermediate value theorem. Very useful, huh? Thank you for watching. I hope you enjoyed the video. See you in the next video.